Let me set the scene. We are outside for a change. The sky is blue, some clouds drifting across the sky. We look to our right and instantly we are blinded by the giant fireball in the sky. Or is it a fireball? It certainly looks like it. Every day the sun produces enough heat and light to power life on Earth. If it looks like fire and feels like fire, then surely that's exactly what it is. Right? Well, let's find out, because the answer might be more than surprising. I've heard countless people say that the sun is on fire. Before we jump to this conclusion as well, we first need to look at what fire actually does. Take a campfire or candle or even a match. They all work in roughly the same way. A fuel reacts with oxygen, releasing energy in the form of heat and light. And as long as there is fuel and oxygen, the fire continues to burn. Take either one away and the flame dies. Simple. Now let's compare that to the sun. The sun has been producing heat and light continuously for around 4.6 billion years. Not thousands, not millions, billions. And that's where things start to fall apart. Because even the most energy-rich chemical reactions we know aren't capable of powering something the size of the sun for anywhere near that long. In other words, the problem isn't that scientists couldn't imagine the sun burning, the problem is that the numbers didn't work. Not even close. If the sun was powered by the same kind of chemistry that powers a fire on Earth, it would have exhausted its fuel a long time ago. Yet every morning, there it is, exactly where it's supposed to be, still shining, still producing unimaginable amounts of energy. And the more scientists looked at the problem, the more frustrating it became, because they knew the sun wasn't an ordinary fire, but they had no idea what it was instead. Let's go back in time for a second. In the 19th century, scientists knew they had a problem. The sun was producing an enormous amount of energy, and it had been doing so for an incredibly long time. The question was, where was all the energy coming from? At first, some thought the sun might be slowly shrinking. As gravity pulled the star inward, it would release energy in the form of heat. Others suggested that the sun was being constantly bombarded by comets and meteors, with each impact helping to keep it hot. On paper, these ideas sounded reasonable at the time, until someone did the maths. A shrinking sun could only keep shining for a few tens of millions of years. The same problem appeared with every other explanation. No matter which idea scientists tested, they always ran into the same wall. Time. The sun was simply too old. And the situation became even worse when geologists started studying Earth's rocks. Their findings suggested that Earth itself was far older than anyone had imagined. Hundreds of millions of years old eventually turned into billions, which meant the sun had to be at least as old. Suddenly, scientists were trapped between two facts. The sun was producing a staggering amount of energy, and it had been doing it for billions of years. Yet every explanation they came up with fell apart under scrutiny. It was as if the sun was hiding something so fundamental that nobody had even considered it. And the breakthrough would come from an unexpected place. Not astronomy, but physics. The answer finally arrived in the early 20th century, and it came from a simple idea that sounded completely absurd. What if matter and energy weren't separate things? What if they were actually two sides of the same coin? In 1905, Albert Einstein proposed exactly that. His famous equation showed that even a tiny amount of matter could be converted into an enormous amount of energy. At first, it was just a mathematical idea, but for scientists trying to solve the mystery of the sun, it was a revelation. For decades, they had been looking for a source of energy powerful enough to keep the sun shining for billions of years. Now, they finally had one. The sun didn't need to burn fuel the way a fire does. It didn't need impact from the comets, and it didn't need some unknown source of energy hidden inside it. Instead, the sun was using its own matter as fuel. Deep within its core, hydrogen atoms are forced together by immense pressure and temperatures reaching millions of degrees. When they collide, they fuse together to form helium, and in the process, a tiny amount of mass disappears. Not because it had been destroyed, because it's been converted directly into energy. Suddenly, everything made sense. The sun wasn't powered by chemistry, it was powered by physics itself. The mystery that had frustrated scientists for generations was finally solved. But that answer raised an even bigger question. If the sun is constantly converting matter into energy, how much of it has already disappeared? The moment scientists realized that matter could be turned into energy, the mystery of the sun was solved. but the numbers they discovered were almost impossible to believe. Every single second, the sun fuses around 600 million tons of hydrogen into helium. I mean, what? Every second? That's already an absurd amount of material. But here is the strange part. The helium that comes out of the reaction weighs slightly less than the hydrogen that went into it. Not much less, just enough to matter. That missing mass is converted directly into energy. Every second, around 4 million tons of the sun simply cease to exist as matter. Instead, they become sunlight, heat, radiation, the energy that powers our entire solar system. 4 million tons every second. By comparison, the Great Pyramid of Giza weighs around 6 million tons. So every second, the sun converts almost the equivalent of Great Pyramid of Giza directly into energy. And it has been doing that continuously for 4.6 billion years. And forgive me for saying, but this raises an obvious question. If the sun is losing 4 million tons of mass every second, how come is it still in the sky? I mean, after billions of years, it should have run out by now, right? And yet the sun remains almost exactly the same object that formed alongside the rest of the solar system billions of years ago. Which means we are missing one final piece of the puzzle. Just how big is the sun really? Because losing 4 million tons of mass every second sounds catastrophic. And if it happened to almost anything else in the universe, it probably would be. But the sun isn't almost anything else. The sun contains around 99.8% of all the mass in the entire solar system. Earth, Jupiter, Saturn, every planet, moon, asteroid and comet combined account for only a tiny fraction of what's there. The sun is that massive. In fact, you could fit more than 1 million Earths inside it. So while 4 million tons disappearing every second sounds alarming, it's barely noticeable on the scale of a star. Imagine removing a single grain of sand from a beach. Now imagine doing it again and again for billions of years. The beach would eventually shrink, but it would take an incredibly long time before anyone noticed. That's essentially what's happening to the sun. Despite converting matter into energy every second, it still has enough hydrogen to continue shining for roughly another 5 billion years, which means our star is currently around halfway through its life. Halfway. Everything that has ever happened on Earth has taken place during just the first half of the sun's existence. And that's when another realization hits. If the sun is only halfway through its life, then one day its fuel will begin to run out. And when that happens, the star that has remained stable for billions of years will begin to change. And it will change dramatically. For billions of years, the sun has maintained a delicate balance. Gravity pulls everything inward, fusion pushes outward. As long as those two forces remain in equilibrium, the sun remains stable. But nothing lasts forever. With every second that passes, the sun consumes a little more of the hydrogen fuel in its core. And eventually, as we said, after another 5 billion years, that fuel will begin to run low. When it does, the balance that has existed for billions of years will start to break. The core will begin to contract under its own gravity, temperatures will rise, and the sun's outer layers will expand dramatically. Our calm yellow star will transform into a red giant. A star so large that Mercury will disappear entirely. Venus won't fare much better. Earth's ultimate fate is still debated. But even if our planet survives physically, it will be completely unrecognizable. The oceans will be gone. The atmosphere will be stripped away. Life, at least as we know it, will have vanished long before then. But even this isn't the end of the story. After shedding its outer layers into space, the sun will leave behind its exposed core. A white dwarf. A stellar remnant roughly the size of Earth, containing a significant fraction of the sun's original mass. No longer generating energy through fusion. No longer a true star, just a slowly cooling ember drifting through the darkness. And that might be the strangest part of all. The object we call the giant ball of fire never burned in the first place. For nearly 10 billion years it will shine not because of flames, but because it can do something fire never could. Turn matter itself into light. The next time you look up at the sun, remember this. What you're seeing isn't the largest fire in the solar system. It isn't burning wood, it isn't burning gas, and it isn't powered by anything resembling the flames we see on Earth. For centuries, people assumed the sun was simply a giant ball of fire. The truth turned out to be far stranger. The star at the center of our solar system has been converting matter into energy for 4.6 billion years. That energy has powered every ecosystem, every species, and every civilization that has ever existed on Earth. And despite everything it has already accomplished, it's only about halfway through its life. And if you're still here, thank you. If you enjoyed the video, consider leaving a like and subscribing. I know everyone says it, but it does really help my channel. You'll also find few astronomy and space related books linked in the description if you would like to support the channel further, along with more content at spaceopedia.co.uk. Thank you for watching, and as always, keep looking up.